Hello everyone. In today's video, let's continue our descriptive and insightful look at network security integrations, this time with Fortinet. My name is Harika and joining me today is Praveen from the Fortinet team. As we go along, it is helpful to have an understanding of network virtual appliances like Fortinet Firewalls, Next-Gen Firewall Enterprise and Geneva tunnels. Enterprise customers who rely on third-party security appliances like Fortinet Firewalls face a significant challenge while integrating these devices transparently without disrupting their existing application network architecture. The top priority for these customers is the ability to insert network security transparently into the network path. The existing deployment architectures require extensive network address translation for the traffic flow. This mandatory NAT process breaks application compatibility in specific cases, making it difficult to adapt third-party security products. Customers want to insert network security without being forced to make network changes to the application deployments. To achieve comprehensive visibility into your Google Cloud Virtual Private Cloud traffic and strengthen workload security, you should integrate specialized network appliances from independent software vendors. These dedicated solutions, which often include deep packet inspection capabilities, enable the full analysis of network packets, examining not only the standard headers but also the actual payload. By deploying these appliances in a bump-in-a-wire configuration, you can instantly gain superior network insight and advanced network security features without making any changes to your current network routing. And it uses Geneva encapsulation to securely send traffic to the appliances without altering the original source and the destination address. By placing a third-party firewall, you can perform deep packet inspection and block unauthorized access in real time. Appliances can inspect traffic from multiple VPCs, projects, tenancies, which helps in scalability. These network security inspections are fundamentally categorized in two ways. The first one is out of band, that is used for the traffic mirroring, and the second one is used for direct intercepting and processing packets. The network security integration solution operates based on a producer-consumer model to handle traffic inspection. The producer VPC network is the service provider wherein you have the third-party network appliances, and the entire setup is called the network service producer deployment. It uses an internal forwarding rule that acts as an ingress point for an internal pass-through network load balancer. The load balancer distributes incoming traffic to the backend either through a managed or an unmanaged instance groups, which contains the deployed security appliances. In this case, it's Fortinet firewalls. When the network service deployment is created, you must reference the specific name of this associated forwarding rule, and network security integration uses this name to route traffic destined for inspection to the producer deployment. The consumer VPC network is where you host your actual workloads on the Google Cloud environment. It can be anything from virtual machines or the GKE nodes. You precisely control which workload traffic is sent for inspection by establishing rules within your firewall policies. These policy rules allow you to specify traffic using various attributes including source destination IP addresses or ranges, network tags or service accounts. Out-of-band service helps in mirroring with predefined rules, and the packet mirroring helps you analyze your workload network traffic at scale by cloning the network traffic based on the filtering criteria specified in the mirroring rules in the firewall policies. This mirrored traffic will be sent to your third-party virtual appliance deployments for deep packet inspection. On the other hand, in-band integration allows you to place third-party firewall where you can perform deep packet inspection, packet interception, and block unauthorized access in real time. As mentioned earlier, the solution here is a service-centric approach wherein you have a producer that can publish scalable set of third-party network appliances as an intercept deployment, while the consumers can use next-gen firewall policies to precisely redirect traffic to a local intercept endpoint for inspection. And the key benefits include the real-time inspection by deploying firewalls and intrusion detection systems directly in the traffic path. This transparent traffic redirection without changing the routing policies using the Geneve headers preserves the original packet information. Appliances can inspect traffic from multiple VPCs, projects, and tenancies, which increase the scalability. This workflow describes how a consumer redirects traffic for deep packet inspection by a producer's security service. The consumer configures a network firewall policy with specific rules. These rules are configured to redirect matching traffic to the producer. When a packet in the consumer's VPC matches the designated firewall policy rules, the redirection process begins. The packet is immediately encapsulated using the Geneve encapsulation by preserving the data, which maintains the packet's original source and the destination IP addresses. It adds metadata about the producer's service for routing. Based on the security profile linked to the firewall policy, the encapsulated packet is sent to the consumer's dedicated intercept endpoint group. The consumer's intercept endpoint group transmits the encapsulated packet to the corresponding intercept deployment group in the producer's VPC network. The internal pass-through network load balancer in the producer's network receives the encapsulated packet and distributes it to a back-end virtual machine which hosts the inspection appliance. The appliance on the VM performs the deep packet inspection. Upon completion, the appliance sends the packet back to the consumer's network via the producer's intercept deployment group. The intercept endpoint group in the consumer's network receives the encapsulated packet, removes the Geneve header, effectively decapsulating the packet and restoring its original form. The original packet is then forwarded to its original intended destination within the consumer's VPC. Today, we are going to discuss how SSL decryption works with network security integration in band to get more granular controls over your application. Praveen, would you be able to show us the demo for SSL decryption with Fortinet Firewall?
Thanks, Harika. In this demo, we'll walk through how FortiGate integrates with Google Cloud's network security integration in an in-band deployment model. Among the many security features that Fortinet provides, this demo focuses primarily on application inspection, including the inspection of TLS encrypted traffic. The entire solution is deployed using Terraform, enabling a consistent and repeatable deployment model. As Harika mentioned earlier, the architecture consists of resources on both the producer side and the consumer side. On the consumer side, we define entities like endpoint groups and endpoint group associations. As shown here, the endpoint group and the endpoint group association work together to identify traffic sources and ensure that the traffic is correctly redirected for security inspection. On the producer side, we have entities like intercept deployment, which consist of a load balancer, FortiGate, and few other networking components. Multiple intercept deployments can be combined to form an intercept deployment group, providing scalability and high availability. As shown here, the intercept deployment group aggregates the intercept deployments and enables a centralized and resilient traffic inspection. Next, we'll log into the Google Cloud Console and explore key elements on the producer side. Specifically, we'll look at the load balancer configured to listen on port 6081, which is the Geneve protocol, with the FortiGate instances serving as the backend instances across multiple regions. Next, we'll look at the firewall policy configured in Google Cloud Platform, focusing on the rules that ensure inspection for both ingress and egress traffic. Both the ingress and egress rules reference the same security profile group created earlier. This confirms that the traffic in both directions is inspected by the FortiGate and its NSI integration. Now let's begin by logging into the FortiGate firewall. Let us look at the Geneve configuration on the firewall. Geneve is configured on port 1. Here we have a firewall policy configured to inspect traffic entering and exiting the Geneve interface. This policy has multiple security services enabled, including application control, web filtering, and SSL inspection. Next, let's take a closer look at the application control profile attached to this firewall policy. As shown here, the profile includes the application filter that uses FortiGate's detailed application signatures to precisely detect and block specific YouTube signatures for streaming and download activity. SSL inspection decrypts and inspects TLS encrypted traffic, allowing security policies to be applied at the application level. This profile is referenced by the firewall policy. Now, let's switch to the Windows client and attempt to access a few websites. First, let's navigate to google.com. As you can see, access to Google is allowed and functions normally. Now let's try accessing youtube.com. Access to youtube.com works well, but when we try to play a video, the traffic is blocked. This traffic is being blocked by the application control policy we reviewed earlier on the FortiGate firewall. Finally, let's look at the FortiGate firewall, and in the logs we can clearly see access to the specific YouTube play functionality was blocked and the event is attributed to the application control feature. This demo highlights how FortiGate's network security integration delivers seamless and transparent inspection and enforcement for both inbound and outbound traffic without requiring any changes on the client side. Thank you so much.
To learn more about network security integration in BAN, please check out the documentation links in the description, and thank you so much for watching.